So, ratio test homework, we had 17, which was the summation from n equals 1 to infinity.
And then 1 over 8.
To the n. All right, and then my mind is like completely blanked. That's a good sign. That's a good start to the day.
Woohoo!
I'm just doing 8 to the n. Okay, yeah. So then we have our a sub n, which is 1 over 8 to the n. And then we have our a sub n plus 1, which is equal to 1 over 8 to the n plus 1. We just want to remember that we go through, and then we have limit as n approaches infinity of a sub n, which is 1 over 8 to the n, divided by a to the n plus 1, so we're going to keep, change, and then flip. And then when we end up canceling this out, we end up with 8. Those cancel out, and you just have 8, right?
Mm-hmm.
8 is greater than 1.
Ah.
I did something wrong.
Yeah, that's where I went wrong. For some reason, my brain wanted to add n plus 1 to 1. I don't know why I did that. But it's fine. We figured it out.
So we diverge. So keep in mind, like, anytime you have this 8 to the n, anytime, like, when you see 8 to the n plus 1, right? That's 8 to the n plus 1 is the same thing as saying 8 to the n times 8 to the 1. Because you're just taking like bases, and when they multiply, the exponents add.
Right.
Okay. As long as we're okay with that.
Yeah, I'm okay with that. I wanted to add n plus 1 to 1. I don't
know why. Oh, I got you. Yeah, if it doesn't have an n, don't add an n plus 1 to it.
Okay.
That's like the part I can't do. I can do everything else. I just can't like cancel stuff out.
It just takes time. Like, it's one of those things that getting used to seeing it. That's why I was saying, like, it's useful knowing that when I see this constant raised to the power of n plus 1, that I can separate it. That way I can make the canceling out easier. Because then it's just like numerators, denominators, and canceling out like terms.
Yeah. Makes sense.
So the bottom two canceled out? Wait, what?
Yeah, because
1 and 1, right? That doesn't matter. It's just 1. But I have 8 to the n. And up here I have 8 to the n times 8. So the 8 to the n's cancel out and just leave me with 8.
And you technically still have a 1 underneath, but because it's like understood, that's just an 8.
Yeah.
Got it.
Okay.
25 n cubed over 3 to the nth. So same idea. You're going to separate out your a sub n. And you're going to get n cubed over 3 to the nth. And then we're going to write out our a sub n plus 1. So we get n plus 1 cubed over 3 to the n plus 1.
I think I did the wrong problem.
Oh, no. Wait, did I pick the wrong problem?
No, that's the right one.
Okay. I was going to say, because this is a possibility. So then we go back again, and we look at it as the limit as n approaches infinity of a sub n, so n cubed over 3 to the n times, we're going to flip this over. I'm going to rewrite this as 3 to the n times 3 to the 1 all over n plus 1 cubed. Maybe that will help with the differentiation of what we're canceling out. Okay.
What's the wrong problem?
So we have limit as n approaches infinity. Okay, so our 3 to the n's, what happens to them?
They cancel out.
They cancel out, right?
Yeah.
All right, sorry. Luke needed some water. So our 3 to the n's cancel out, right?
Right.
We have our n cubed. There's nothing else in common. We have our 3. There's nothing else in common, so we have a times 3. So that's just 3n cubed all over. And there's now another n plus 1. So we end up with n plus 1 cubed. Hey, what's going to be the highest power in the numerator and the denominator?
3.
3, right? So up here, I'm going to rewrite this as... Just so we have, like, okay, the highest power is going to be n cubed in both cases. So remember when we have that, we just take the coefficients of the n cubed. Here it'd be just 1. So we end up with 3 is greater than 1, so it diverges again.
I think where I'm going wrong is I'm setting up, so like the part where keep, change, flip, I'm setting up that part wrong. I'm doing a sub n plus 1 as normal, and I'm flipping the a sub n, but it's really you need to flip the a sub n plus 1.
Yeah, you keep the original, so you keep this original function, and then you flip the other one. And I'm skipping that original step of like the setup just to help you save some space, and because I think it's easier to think about this way.
Yeah, I like that a lot. I just was keeping the wrong a sub n.
Okay.
So that's where I went wrong.
So are we okay here? Do we have any other questions?
I'm good. I don't know about Mackenzie. I haven't heard from her.
Okay. I'm going to flip the page.
I'm gonna go get my coffee.
Okay.
Be right back.
So this leads us into root test, and the root test example that we have isn't drastically different. They have this idea that same instructions as yesterday, determine convergence or divergence. And we're going to use the summation as n equals 1 to infinity of e to the 2n over n to the n. So the way root test works is you have n in both of the powers, correct?
Correct.
All right, so then you have a fun time and you take the limit as n approaches infinity of the nth root of the absolute value of a sub n. That's our little property from yesterday. Okay. A sub n's already here. We already know it. So really what we're doing is we're saying the limit as n approaches infinity of the nth root of e to the 2n over n to the n. So that's our setup. The nice part about this is the following. Whenever I have this radical idea, what I'm really doing is I'm saying the limit as n approaches infinity of e to the 2n over n, and then n to the n over n. Because the way a radical works, right? If we think about the nth root of x, I'll write this out to the side. That's the same thing as saying x to the 1 over n. Right? So like all I'm doing is I'm dividing those powers by n. Are we okay with that part?
Yeah.
Okay. So the nice thing that means is we get limit as n approaches infinity. And then this is just going to be e squared over n. Hey, if I plug in infinity, where am I going?
To 0.
To 0. 0 is less than 1. And because of that, it converges.
How do you know if it's going to 0 or things like that? Like how,
Okay, remember, if your highest power is in the denominator, so in the sense like we have an n down here, not a, or we have an n in the denominator, not in the numerator. So this infinity means that fraction, the denominator is going to keep getting larger and larger and larger, which means I'm going towards 0.
Okay.
If my n, let's say it was flipped, it was reciprocal.
Okay.
If the highest power is in the numerator, then it's going off to infinity. If the powers are the same, you take their coefficients.
Okay. I'm just gonna probably keep asking that question until it sticks in my brain.
I mean, that's
'cause
fine. It's one of those things. Like as soon as like once it sticks, you're like, oh, okay, this isn't so bad. But until then, you have to keep reminding yourself. It's one of those things that's it came up at the beginning of the year, but then you don't see it again until now. So it's just one of those. One of those things to kind of keep track of. The good news is that's the root test. Like it's as simple as doing that each time. So it's a lot easier than the ratio test.
Sounds good.
I'm back.
Welcome back. I talked about the problem already, but I'll go over it again.
Oh, good, because I don't understand it the first time.
Okay, only if Mackenzie struggled to.
All right.
I don't want to be burdened.
That's only for me, right, Lily?
No. This is fun.
Yeah.
So anytime you have like each thing to a power of n, you're going to use the root test, which means you're going to take the nth root of whatever the absolute value of a sub n. Well, a sub n's already here, so we're good. You're just plugging that in. You just have to remind yourself that when you see the nth root, it's the same thing as raising everything to the 1 to the nth power. So you're really just dividing these powers by n, which leaves you with e squared over n, and then you substitute in your limit of n approaching infinity. And since the n's in the denominator and there's no n's in the numerator, it goes towards 0. So 0 is less than 1 and it converges.
Oh, okay. Makes sense. You can go on and continue.
So not too bad.